Okay, chapter 7, we're going to update our notes, so make sure you've printed your guided notes. I'm going to change this a little bit. Chapter 7, linear regression with summary statistics from data. I don't know why I have the and in there. We'll get rid of that right now. So, we're going to learn to create linear regression equations from summary statistics today and from data. That'll come tomorrow, though. Today, just summary statistics from data. Okay, so there are different names for a linear regression line. If you hear any of these, you got to be familiar. One, linear regression line. Okay. Another one, best fit line. You could also hear line of best fit. Then you could hear least squares regression line, sometimes abbreviated LSRL. If you hear any of those, you're doing the same thing. You're finding the best fit line. So it doesn't matter what name we give it. One of those, that's what you're doing. Now, in algebra, we should know how to graph from algebra, y equals mx plus b. If you don't, we'll review it. But remember, whatever number is next to x, that is your slope. And the number that is the constant, that's your y-intercept. So we always called in algebra, the slope was m. So our slope, m equals negative 4/5. Our y-intercept b is 7. Now, realize if you took a 0 and you substituted 0 in here, negative 4/5 times 0 would make that go away. We would have the point 0, 7. That is the y-intercept. So 0, 7 is our y-intercept. We'll go up and we will put a point for the y-intercept. Now next, any other point on this line, you would apply the slope. A negative 4/5, there is only one negative. Make sure when you do this, you don't do two negatives. It's either negative 4 over positive 5, or it's positive 4 over negative 5. I apologize for writing with a mouse. It kind of jumps around on me, doesn't do the best job. I used to have a nice touchscreen. They took that one away from me and gave me a different one. So anyway, down 4 from this point, 1, 2, 3, 4 over 5, 1, 2, 3, 4, 5. That would be a secondary point. Then we can draw our line. But we can also do it the other way. From this point, we can go up 4. It's going to be a little harder because we get off the graph. 1, 2, 3, 4, and then left 5. And we should end up in that same line, drawing the line with a mouse again. Kind of tough, but that wasn't too bad. But that would be our graph. Okay, so that's algebra. It's mx plus b. If you're using Desmos, Desmos is going to have it in the mx plus b form. That's okay, but the equation that we will get on our formula sheet, if you have a formula sheet, it's helpful to have the formula sheet out. It is y hat equals a plus bx. So what are these different things? Make sure you're filling these in as you go through the notes. Y hat, that value y hat, the reason for that little hat on it that we call the hat is because that's the predicted values. So sometimes you're going to see a y with a little hat on it. Sometimes you might see the word, again, I hate writing with the mouse, but I'm going to do it here. You might see predicted y. Okay, so the predicted value of y. Those two things mean the same thing. This equation is built to predict y. So we will substitute for x. The only things that we put in here will be the explanatory variable. You should never substitute in this equation for y hat to try to predict x, because the equation isn't built to predict x. And in fact, if you do that, it's not going to make a correct prediction. You'd have to write a different equation. X equals a plus by, x hat equals a plus by. You can reverse the variables, you could do that, but you would get a totally different prediction than if you reverse engineer this equation. It won't work the same. And the a, though, that is the y-intercept. So that's the equivalent in algebra of our b. So this equation, this would simply be A, and this would be B. We would graph it the same way. They just write it in the reverse order in statistics. I don't want that to confuse you. So, you know, if we wrote that same equation from the other page, we'd go y hat equals 7 minus 4/5 x. And we would graph it exactly the same way. It's no different. So A here is the y-intercept. B is the slope. If you should know that because you're going to need that from the formulas, but if you realize it's just b plus mx, that is the same thing. In algebra, you graph it the same way. It's just giving us our y-intercept first, which kind of makes sense from the statistical standpoint because you graph the y-intercept first and then you apply the slope. So in statistics, it makes sense from that standpoint. In algebra, we usually write things in descending powers of x. So it actually, both forms kind of have something that makes sense. Which one is right? Well, they're both right as long as you remember what you're dealing with. So B in this case is the slope. And it is about the rate of change, just like we learn in algebra. The y-intercept, remember, is what the y value is when x equals 0. That's going to be important, and so is the fact that it's a change for the slope, and it's for a 1 unit increase in x. I would recommend that you circle that. That's going to really come into play this chapter. X variable is the input variable. And that's the one we input. We never input for y because y is the one that we're trying to predict. So we don't put something in here for y and find x. That will not get an accurate prediction for x because this equation wasn't built to predict x. It was built to predict y. All right, so let's jump into this. And here we've got y hat equals 5 plus 3x. So pause the video as needed. I'm going to jump right in to do this. So pause it if you need to. Here we go. Our y-intercept, that's A. So A is 5. I'm going to go up 5 and I'm going to put a dot. Now, the slope has a 1 unit change in x, so you can always put your slope over 1. Whether it's a decimal or whether it's a whole number, you can always put it over 1, and then you could do that. This one says it goes up 3 and over 1. If you're like, well, I'm running out of room, I don't want to do that. You could also go down 3 and the left one. That's still a positive slope because a negative divided by a negative is a positive. And we get the same line. So first of all, hopefully remember how to graph the lines. Now this is the best fit line. We don't even have any points on there. We'll talk more about those as we go. But here, today's lesson is on finding the regression equation when you have summary statistics. So here I'm giving you some statistics. They're on your notes. X bar is 12.5, Y bar is 68.3, S of X 3.8, S of Y 9.2, and R is 0.85. I want you to get your formula sheet out. You kind of don't have to because I was nice and put the formulas that you have right here in your notes. I've got to extend that page, can't quite do it. And you got these formulas. The ones that you're going to need is you're going to need this one. This is the generic formula that I gave you on the other page. And then you need this one for B. And then this one will help you find A. Now, I would recommend you take this one and you solve it for A. So A, if I were trying to find A, I would subtract BX, and this is another formula. This is the way they used to put it on the formula sheet. Y bar minus B times X bar. Okay, and that's how you can find A right away. But you can use either of these. It's the same formula. I'm just rewriting it. So I'd like you to take those, and I would like you to just pause the video again. I'm going to jump right into it. I'm trying not to sneeze here. I'm probably going to sneeze. So excuse me for that. But I'd like you to jump in. I'd like you to find A and B and write the equation. So for this video, that's going to be the goal. Write A and B, find the equation. We're going to do that on 2 of these, and then we're going to call this video good. Okay. So I assume you have paused the video, but I am going to jump in and I'm going to do these. And again, excuse the mouse writing. All right, so B, how do I find B? I take my formula. It's B equals R times S of Y over S of X. So I need my S of Y, 9.2. I need my S of X, 3.8. And I need my R, 0.85. And I'm going to put all those into this formula for B. Now, if you didn't figure it out, take that B, pause the video, do it, use your calculator, type it up, away you go. So B equals R times S of Y over S of X. 0.85 times 9.2 over 3.8. And what'd you get for B? I'm guessing you got 2.058. Okay. So now you've got B. Now with our 2.058, we have to find A. So again, A, this is the equation you need for A, and you can either go Y bar, 68.3, equals A plus B, which you just found B is 2.058, times X bar, 12.5. So I'm going to do that on this page just because it's a little easier. So again, 68.3. Now I'm going to use this one. 68.3 subtract B, we just found to be 2.058. Times X bar, which is 12.5. And you get A, and A should be 42.575. Now the last step to write the equation, you take this one, y hat equals A plus bx. So you have A is the y-intercept, and B, 2.058, that's the slope, and X, and you put it into the equation. So we take our A and our B, and we just slide them in. Remember this one, B goes next to X, A goes next to Y, and that's our equation. Y hat equals 42.575 plus 2.058X. Okay, hopefully that makes some sense. Now I'd like you to try it again on this next example. So this next example, this time we've got some more information. We've got X. X is the study hours. And the test score is Y. And how do I know? Well, it says test score, and then it gives me a Y bar. Okay, so now nothing has changed. You just take these, you find A, and you find B. You put them into your calculator, you do those. So again, if you would pause the video, take your time, do this. If this were live in class, like I've said, then I would have students do this. If you're not trying it on your own, you're not learning it. Fortunately, my online students know that if they don't try it, they're not going to learn it. I think online learning is many times difficult, and when you challenge yourself and you try an online learning class, the one thing you learn to do, you learn to work independently, and I'm very this year in 2025, very proud. I don't have as many as online students as I've had in the past, but I've got some very hardworking students, 6 students this year, and watching this video for the first time because I just made this one. I'm very proud of all 6 of you. You're working very hard, so keep that up. Okay, so unpause the video when you're ready, and here we go. So again, B equals R. So what's R? R is 0.72, so I'll put that in, times S of Y. Now, S of Y goes on the top. One of the things, if you remember from slope, it's always Y2 minus Y1 over X2 minus X1. The Y's go on the top. So I always said in algebra, when you were doing the slope, it was the yummies go on the picnic table. Okay? Silly thing, but you always put the y's on top because then the bottom looks like a picnic table. And then you subtract your y's, so it's y2 minus y1 over x2 minus x1. You don't put the picnic table on top because it squishes your y's, and they become yuckies rather than the yummies being on the picnic table. Yes, very lame, I know, but kind of funny. So you put your y on top. So always make sure your s of y is on top. That's still, because standard deviation is about it's about the change in y. It's about how y changes, and that's what this is. This is a change in y over change in x. And change in x then is s of x, so over 2.5, okay? So again, you've got a calculator. You go ahead and you do that, 0.72, 11.4 over 2.5. I could ballpark it, like 4.7. I don't know, 3 something. And it's 3.283, okay? I'm going to come back to that, but that's 3.283 is our B. Okay, now we need our A. So if you've reversed engineered it and solved it, you know, where you got A all by itself, it's y bar 81.6 subtract B, which was 3.283 times x bar, which is 8.2. Mm, 24, 25-ish, I don't know, 60, 50, 55, 56 range, somewhere in there. 54, okay? So it should get 54.679. Okay, now the equation, I understand, it is y hat equals A, 54, I'm just going to abbreviate 54, plus 3.2 times x. Okay, if you wrote this now on a test, I would give you 1 point and I would subtract 1 point because what I want is the context. I'm giving you some context here, and x is study hours and y is test score. So instead of y, I'd like you to write something like this and put predicted test score. Whether you put the word predicted, I'm going to cross that off and put on the hat. The predicted test score, remember the hat means predicted test score, equals 54.679 plus 3.283 times the study time. So instead of putting x and y, you put that. If you write this, you can still get this right, but then you have to write something like y is the test score and x is the study time. Okay, so hopefully those make sense. That is lesson 1. We're going to end there for today. Thanks for watching. We'll get another video going for tomorrow.